This video is about kinematics problem. Guided practice 1. A particle moves in a straight line with a displacement function s of t equals 12t minus 2t to the third power minus 1 centimeters, where t is in seconds, t greater than or equal to 0. A. Find the velocity and acceleration functions for the particle's motion and draw sign diagram for each of them. We do know velocity equals derivative of displacement, which means 12t minus 2t to the third power minus 1 prime equals 12 minus 6t squared. For acceleration equals derivative of velocity, which means 12 minus 6t squared prime equals negative 12t. For sign diagram, velocity equals 12 minus 6t squared. We need to figure out 0. 12 minus 6t squared equals 0. T squared equals 2. Since t is greater than equal to 0, we know t equals square root of 2. Then for the sign diagram, velocity let's choose a number 3, then plug back in. Velocity of 3 equals 12 minus 6 times 3 squared less than 0. This is a negative. This is a positive. This is the sign diagram for velocity. For acceleration, since t is a positive, negative 12t always negative. And also a of 0 equals 0. This will be the sign diagram for acceleration. Let's go to B. Find the initial conditions and interpret its meaning. S of 0 equals 12 times 0 minus 2 times 0 minus 1 equals negative 1. Means the particle is 1 centimeter left from the origin. V of 0 equals 12 times 6 times 0 squared equals 12. The particle is moving right at 12 centimeter per second. A of 0 equals negative 12 times 0 equals 0, which means the particle has a maximum velocity. Look at the C. Find the time and positions when the particle changes its direction, which means we are looking for V of t equals 0. We already figured this out in A. T equals square root of 2. So S of square root of 2 equals 12 square root of 2 minus 2 times square root of 2 to the third power minus 1. So we have 8 square root of 2 minus 1. The particle is 8 square root of 2 minus 1 centimeters right from the origin. For the motion diagram, this is a displacement. This is origin. Then when t equals 0, the particle is 1 centimeter left from the origin. When t equals square root of 2 seconds, the displacement is 8 square root of 2 minus 1. So the particle at t equals 0, moving to the right, then change its direction at t equals square root of 2. So we draw this way to show change the direction. This is the motion diagram for the particle. Let's go to E. At what times is the particle's speed increasing? Velocity increasing. Speed increasing when the velocity and the acceleration have the same sign. Look at the sign diagram for velocity and acceleration. When t greater than square root of 2, then the velocity and acceleration are both negative. When t greater than square root of 2, the speed is increasing. Velocity increasing means we need to figure out acceleration greater than 0. From the sign diagram, acceleration always negative, which means velocity never increases. So t is an empty set. For F, what's the total distance traveled in the time from t equals 0 to t equals 2 seconds? Distance traveled, integral from 0 to 2 of absolute value velocity dt, integral from 0 to 2, absolute value of 12 minus 6 t squared dt. Math 9, from 0 to 2. Absolute value, go to math, number, absolute value. 12 minus 6x squared dx equals 14.6 centimeters. Let's go to G. What's the displacement traveled in the time from t equals 0 to t equals 2 seconds? The displacement equals integral from 0 to 2, velocity dt equals integral from 0 to 2, 12 minus 6t squared dt equals 8 centimeters.